I'm going to talk to you about secrets of a great API. And it's funny because it's not really secrets. It's more just a question of having collected enough experience and talked to enough people, some of you out there, to gather a list of things to really be thinking about when designing for a very successful API initiative or API strategy. So let's start with a few lessons that I've learned sort of the hard way from the battlefield out there of APIs, having been doing this for the last few years. I wanted to take you through a few examples really quickly before diving into the meat. One of the companies I had the fortune of being at was Aptana. Aptana offered tools for developers for developing Ajax front and back ends, for deploying those to the cloud. And we also offered something called Jaxer, which was a predecessor to Node.js, to actually implement that functionality on the server. And what was interesting there with regard to APIs is we worked with a great company called Joyent to create our Aptana Cloud offering. And they had exposed an API. It was very early in its days, but they said, here's a great API to use to actually interact with our cloud. You can create effectively instances, you can provision them, you can do a lot of things through this API. So have at it. And when you're developing your cloud offering, go ahead and work with this API, one of the first customers or partners to go out and use it. And we didn't perhaps have enough of the experience to really kind of probe into the maturity of the API. And so we went ahead and kind of assumed that everything was there, was good to use. And we incorporated API calls along with everything else into our automated testing. And as a result of that, we could spin up numerous new instances and call their DNS server numerous times per second as a matter of course in our automated testing, without us realizing and without their realizing how much load we would end up putting through their API and how many kind of end cases we would end up exercising, and ended up causing a little bit of fortunately temporary damage to some of their services, in the sense that we had some downtimes and we had a lot of issues until we ironed out exactly how we could work together in such a way that we would not be bringing them down and that we would still accomplish the end user goals. And it turned into a great partnership later, but I think the lesson that I learned there is really understand the maturity of the API. It's going to start early, and then eventually it gets more mature, but communicate very clearly and openly the state of your API, throttle if you need to protect your internal systems, and make sure that that API experience that you're giving your partner or your customer is a very, very solid one. Another company that I worked at was eMeter. eMeter delivered enterprise solutions to the utility industry to support their smart grid initiatives. So if you have a lot of smart meters out there and they need to bring in a lot of data, tremendous amounts of data as it turns out, into the utilities data center, eMeter provided large enterprise grade solutions to take that data, cleanse that data, transform it from the various formats that are out there, and then run various important applications, billing applications, outage applications, and so on. So it was a very large enterprise on-premise system, and I was brought in to help them define the approach towards building a consumer offering on top of that. And so the question was, how can you actually create an interactive website at that time that consumers would go to on a regular basis in order to see how much energy they've used, compare it to their neighbors, and so on, right? If you are at all like me, the notion of going regularly to your utilities website in order to interact with it is a little bit foreign, right? You got to get people to actually go there, and that means you have to create a very engaging experience. Maybe it's one of competing with your neighbors, maybe it's new ways of saving. How do you create this very engaging consumer experience? Well, typically you have to have a lot of iterations, you have to have a lot of feedback from your customers. You want to evolve that website very quickly until you really find the ways to resonate with your consumers. And it's very hard to do that when you're sitting on top of this huge enterprise system. Enterprise systems tend by design to move very slowly. At least these did. Utilities didn't want to take upgrades to their systems very often. So we needed to create an interactive, very agile process in front of a very large and slow backend. And the key to that was to actually define at the beginning a contract a set of APIs that the backend enterprise platform would have to support, and that the front-end consumer-facing website would be built on top of. And there would be no other dependencies between the front end and the back end. Once we identified what that contract was, and that didn't require lots of iterations, it required a few until we kind of understood the overall capabilities we would be needing from the backend system, we could actually mock out the backend and let the enterprise backend take however long it took to actually implement that. But we could actually put a real front end in front of consumers very quickly on top of this mocked API and get some feedback and iterate quickly. And even in the future, once we had it out there and the API was really running in the back end, if we needed to tweak the front end, no problem at all, because we knew that that API contract had been established with the back end. We knew that part would not actually have to change. So having an API in place is what allowed us to successfully take a consumer website to market without destabilizing the enterprise backend that backed it up. That was absolutely critical. And one more lesson to bring to you was in my previous position when I headed up the Nook Cloud. One of the things the team did was, of course, to create a set of APIs to enable the Nook devices and other devices to actually talk to the backend. And an important lesson early on was that even though those APIs may not have been ideal, may not have been perfect, the fact that they had been good enough to ship a product and to actually iterate on it a couple of times was amazingly critical. So I think the lesson out of that was, if the API is good enough, ship it. Put it in the hands of consumers, put it in the hands of other developers, and use the opportunity to actually get some feedback about it. Another important lesson was a layer cake. We had layers of APIs. We had APIs on top of APIs. That was actually a really good thing. As developers, it's very common for us to say, well, let's just build one API to serve all purposes. It's absolutely not the way that things work there, and not the way that they should have worked there. There were very fine-grained APIs around search, around specific product information. There were coarse-grained APIs that the devices actually interacted with, and that was absolutely correct. Each one, as we'll go through this talk, we'll see this, each one kind of had its own purpose and did so successfully. One of the pitfalls that we saw of stuff that we did there, one of the problems that we actually saw was around the code first approach. And it's a very illuminating story. We had a new piece of the back end to ship, or rather to implement one particular year, and that was a new digital catalog. And as part of that initiative, we were doing lots of very interesting things, building a lot of things, and the API of that catalog wasn't actually front of our mind. And sometime pretty late in the cycle, we realized that there needed to be an API on top of that, so that one of the functionalities of the Nook ecosystem that was relying on that digital catalog could actually access it. So we said, no problem. We took that the code for that API, and some people added some annotations to it, and sure enough, an API emerged out of it, right? That's one way to really quickly get an API. Of course, what that API did is it reflected directly the code and the classes and the structures that the actual catalog had underneath it. And so, for example, if you needed to actually make a change to a product, you would do a get on a particular resource. You would get, I think it was something like a couple of megabytes, maybe more, of data, and then you would hope to manipulate just a little bit of that, but submit the entire object back. Of course, the chances of it actually passing validation were small, and it became a very, very hard to consume interface. And the team really had to scramble at the last moment to change that API so that the people who consumed that interface could do so in a meaningful way, and were not completely coupled to the implementation of the catalog under the covers. It was a really important lesson for how you should use the APIs to actually decouple systems rather than just expose your internal systems. And fortunately, again, that was done, managed to ship and actually have a successful season. So it's on the back of systems like this and companies like this that I've been involved with that I've derived some of the lessons I'll share with you today. So one of the most important lessons is really where to put your focus. And I'm a strong believer in putting your focus on something called the APX, or Application Programming Experience. The idea is, think about the people who are consuming your APIs and what experience you want them to have in terms of the form of the API, how they get access to that API, whether that API makes sense to them, and put all your eggs in that basket. If you, or at least most of your eggs in that basket, if you get the APX right, then you're much more likely to actually succeed once you implement the API behind the scene. So in order to actually do proper APX, and I should say one word about APX, the reason we came up with this term is if you look at user experience and user interactions, for a long time now, people have said, don't just think about individual pieces of your UI, think about the whole UX, think about the whole experience of your user. And it's similarly with APIs. We believe that you should not only be thinking about the specific API, but rather what kind of APX, application programming experience, your developing users, your developer consumers are going to have. So let's talk about that consumer. Who is your customer, right? Think about who your customer of that API is right now, but also a little bit in the future. Right now, it might be, some guy in the basement trying to build an app on top of your API, but if that API is good and successful, you're going to have lots of other people consuming that API. Put some time into thinking about them. Now, the flip side of this is, when you're really trying to get into the heads of those consumers, you may end up realizing, well, the whole world might be consuming me, and thinking through all the possible use cases and actually getting paralyzed by having to think of how to meet all of those requirements. So avoid that by thinking about sort of likely pool of customers and limit it to that, realizing that if a completely different pool of customers comes later, you can always build another API that meets their needs. And finally, I was talking about having a single API for everything. Commonality is good, right? You want to try to find some common approaches or some common principles to reduce the complexity. We'll actually talk a lot about that in this webinar. But don't try to shoehorn everyone into exactly the same API. Your mobile developers are going to require different kinds of APIs and some of the partner integrations. So think about common things, think about common patterns, but don't try to shoehorn everything into exactly the same API design. Next, think about what is your value add as an API provider, right? You might be the part of the ecosystem that's actually orchestrating some services. So you are serving the consumer developers directly, and you are the one taking into account all the orchestration of the services behind the scenes, right? In that case, you're going to be paying particular attention to the APX, starting from the APX that you'd like to implement, and then figuring out how to do it behind you. On the other hand, if you're a single purpose service, let's say a search service or a fraud detection service or something of that sort, you're going to be paying most of your attention to the quality of that service and exposing an API that's consistent with that service. You shouldn't be thinking at that point about the end user experience. Let the people who are doing the orchestration think about that end user experience, and make sure you give the best API for the particular service that you are exposing. Another question is, are you putting together an API for back-end consumers or front-end consumers? Back-end consumers on the left are going to be, for example, businesses or other business units that are integrating with your service. And in that case, you are thinking business processes. You're thinking how you can expose APIs that allow people to build business processes around your services. If you are providing APIs for front-end developers, you're thinking very different things, or at least your users are. So they are thinking, how am I going to get my API with the least number of calls? How am I going to understand a very complicated back-end domain model? Maybe don't make them understand a complicated domain model. Make sure that the API exposes a domain model that they will understand. So your concerns are quite different. Another example is, are you effectively a straight-through proxy, or are you a new facade that creates what looks like a new service? So if you are proxying an existing service and basically trying to allow people to access that service, we often call that part of legacy modernization. You want to look at the service that you're exposing. Say it's a database of customer information, and you want to expose an API that abstracts that out, but still carries the concerns of that back-end system, right? So if it's a business process, the API should reflect the domain of that business process. If it's around a database, it should be the domain model of that database. So you're kind of looking backwards in that case and figuring out what is a good abstract way to express the domain model of the system behind you. If you're a new facade, you're basically trying to create a new service based upon some capabilities behind you. So you are looking forward and saying, if such a service were to exist, what would be the proper facade for it? And even though behind the scenes you're doing a lot of integration, in front of it you want it to look like a uniform, coherent service. So look forward in that case. Okay, now going back to APX, a few critical principles to leave you with. One is, in this case, unlike many other areas in computer science, this is the place where you don't necessarily want to be completely transparent and show people everything that's going behind the scenes. This is about an interface, and it's a long-lived interface. So it is the way that your customers will see you for a long period of time. It is worth the thought. It's worth taking some care into it. Even if you have some dirty laundry behind the scenes, that's fine. Go back and clean up your dirty laundry, but expose the interface that you want your clients to develop a dependency on. Because if you simply make this a window to your backend systems, they will grow a dependency on your backend systems, and you don't want that. Speaking of exposing dirty laundry, this is exactly the kind of thing that I encountered at my previous company, where if you simply reflect the backend model, guess what? You've now tied them in all the way through to your backend model. And even though it may be very tempting to go with some solution that simply, let's say, puts an API automatically on top of your database, that API will reflect your database. And so if you ever need to change your database, business has changed, your technology has changed, it's going to be very hard to change that API and break all the clients that depend on it, right? Instead, come up with a simple, long-lasting domain model, something that is going to be not needing change, because it is pretty much the only or a reasonable way to model your interface regardless of the implementation, and then implement to that interface. Finally, really craft it, right? I think we've seen time and time again that the winners in many spaces are the ones that pay maniacal attention to the product that they are creating. And the product here is your API. And your consumers are the developers. So craft it for those consumers. Will they love it? Like in this picture, a guy absolutely loved old-fashioned cassettes, and there's a table that's crafted, and you can bet that over time he's going to find reasons to avoid any temptation to actually go to a different kind of coffee table. So similarly, your users, if your API is really good, will actually get maniacally attached to it, and that's exactly what you're shooting for. Okay, so now here's a checklist of things to keep in mind of what your users will need. So for example, how will they discover that you have an API? We've seen over and over again in enterprises that people build the same service multiple times because they simply didn't know that some other group had already built something like that. Make it easy for people to discover APIs. Give them multiple channels to discover whether some work was already there. How will they actually explore that API? Do they need to create their own little infrastructure to go and ping that API? How will they get access to it? How will they script against that API and capture use cases? At the very basics is, how will they access it at all? Are they going to have to send emails around and figure out who owns the control of the access to that API and get access to it that way? Or is it a self-service model? Is it a quick turnaround on that self-service model? Presumably you want people to access that API, so make it easier for them to do that. And then how will they actually build on top of that API? It's one thing to say I have an API that's now in production, but not necessarily can all business processes actually be carried out on that production API. Are you offering them sandboxes? Are you offering them sandboxes that have realistic data so they can actually build their sandbox or their prototypes on top of it? This is something where I've seen in my career a lot of pain around not anticipating enough how many sandboxes need to be created and how will we actually manufacture the correct data to actually put on top of those sandboxes. If you take a snapshot of production, it might be a big problem because of privacy concerns. If you manufacture data, well, your data is only going to be as good as the algorithms used to manufacture it. So a lot of complexity around that. Make sure that you've thought through that in addition to just the form of the API. How will they be able to verify that that API is actually working properly? And that goes back to the previous question of how do they know that the data there is proper? If you provide, for example, a non-secured sandbox API, how will they verify that their security authorization is actually going to work? If the security is through integration with, say, your LDAP, will your sandbox have a similar LDAP that it can use to do the authentication? And finally, of course, running on it. So have you thought through the SLAs? Have you thought through how much traffic you can take? Do you have throttling mechanisms? Do you have ways of controlling how much traffic goes to one consumer versus another consumer? And no API lives forever. All APIs eventually get versioned. So how do you take your users from one version of the API to the next version? Do you have communication channels with them? Have you established a versioning policy? Do you have terms around how long a version is supported before, once it's deprecated, before you actually take it out of service? So with this checklist, you need to actually figure out how and where you will publish your API. How will you actually describe this API? What format you'll use to describe the API? What tools you'll give people to explore it? How are you going to give them access to it? How will you allow them to work off a mocked service while you implement it? And how will you implement it? Do you have the tools to efficiently implement it and maintain it over time as your back-end systems change? We talked a lot about sandboxes already, but how about operational issues of having, say, a small team of beta testers and then a larger team of developers who access it, and maintaining that community over time? It absolutely becomes a community. And finally, communicating to them the versioning and deprecation policies. Now, not too surprising, but a 2-cent pitch to MuleSoft. We do have solutions for this entire life cycle. And we encourage you to check them out. We have an API portal, and we have a lot of tooling specifically around RAML, which I'll talk about in a moment here, to allow the discovery and exploration and the whole APX cycle. API Manager allows you to easily manage who has access to that in a controlled and secured manner. And then you can implement that if you choose to do that on our technologies using our Anypoint Studio, an API kit. You can run it on Mule on-premise, or you can run those APIs on CloudHub, our cloud offering, depending what makes sense for you. And finally, complete that cycle by using the API Manager to actually operate it that way in production, if that's what you choose, and at the very least, engage your community through our API portal technology to be able to communicate with them, allow them to explore that API, and eventually version it and deprecate it. Okay, now what kind of API? Let's talk a little bit about types of APIs or the forms of those APIs. So a very common one for enterprises, I don't know, maybe half of enterprise APIs right now, internal and external, maybe more, are based on SOAP, described by WSDL, the Web Services Definition Language, and going over HTTP. Another bunch of APIs, and this is growing in acceptance. I don't know whether it's quite overtaken SOAP and WSDL in the enterprise yet, but it certainly has for all of open APIs, and that is REST or RESTful or mostly RESTful APIs, which basically say take HTTP seriously and use the provisions already built in HTTP to provide a lot of the capabilities of your API. It provides a tremendous amount of simplicity. Sometimes it's overly simplifies, but usually it's a very nice organizing principle to create your APIs. And one of the very first paradigms of REST is around resources and entities. So, for example, you would get the list of users by issuing an HTTP GET command to a resource at /users. And you would return in HTML land a page of information about users, and in data land a collection of data items that represent users. In many cases, you will end up mixing and matching a variety of APIs. So, for example, Google protocol buffers, if you need a strongly typed API with automatic SDK generation on both sides, you can use GPBs. It's one of the popular choices, and use them over HTTP. GPBs themselves are binary, so you lose some of the benefits of text-based interfaces, but you gain some other benefits. You have to make your own calculation if that makes sense for you. WebSockets is another interesting transport level protocol. It acts like HTTP on the outside, but underneath it gives you more like TCP-like capabilities. And what data you actually exchange over WebSockets, well, you have quite a pick. Nothing is really standardized around that. API facades. So here's one interesting palette that we see repeat itself often enough that we've actually given it a name. We call it a REST mullet, right? Mullet in the sense of a haircut. You've got REST in front and SOAP in the back. Your consuming developers want to see REST. The backend services are already implemented in SOAP, and so you need to have some layer that maps the REST APIs that you're exposing in the front to the SOAP APIs you've already done in back. Another kind of facade is something on top of SOA. So you've already got a SOA initiative inside your enterprise. You've exposed a lot of things as services. Maybe they're SOAP-based services already, and you need to go and have your clients talk to them. So you take whatever technology you've chosen to expose to your clients. Maybe it's protocol buffers, maybe it's just RESTful interfaces, maybe it's MQTT, and you build something that takes those SOA services and exposes them over these protocols. So very often you're putting an API facade on top of some existing services. Okay, here we're going to concentrate quite a bit on REST for a variety of reasons. One is it's growing in popularity. And the second is, for a lot of enterprises, this is actually the area that they're looking for a lot of guidance on. So I'll spend most of my time here on that. So here's the practical aspect of REST. And the reality is that there's a lot of almost religious level debates around REST. There's certain principles that some people espouse very, very heavily. And there are certainly benefits to going down those roads. But I'm going to take a perhaps more practical approach to today's API landscape and concentrate on those areas where most of the API implementations around RESTful or practically RESTful APIs are falling down on. So I think the major reason why REST has gotten the kind of adoption that it has is its simplicity. In contrast to a lot of the enterprise standards and SOAP and WSDL and WS star and all of those things, people have just gone back and said, look, I need something that's a lot more simple. I need something a lot more agile. And look, here's this beautiful paradigm around REST that I can use to build my APIs. So a major tenet of REST is look at your resources as the nouns of your object model, right? The things that you are going to be operating on or getting the information on, the nouns, are your resources. So some examples of that. Well, all of those examples are going to be around the specific domain of your API, right? If you're in an e-commerce setting, you'll have one set of nouns. If you are in media streaming, you'll have a different set of nouns. If you're in enterprise security, yet another set. So carefully consider what are the objects, the natural objects that make sense in your domain, and craft your API around that. Another aspect here is the query parameters. Are they actually a part of the resource, or are they refinements on the resource? My opinion, they are refinements, and I'll show you an example of this right here. So let's say I want to talk about a collection of users, right? The resource might have a path of /users, and I'm going to use paths here in order to identify those resources. What about this collection of resources, right? It's the resources that have a particular zip code and that are subscribed to my service. So that's great for a GET request. It tells me which subset of the overall user pool I'd like to get. But how about posting to /users? If I post something to /users, I'm trying to create a new user. If I have this in the query string, does that mean that I'm declaring that the user actually has this zip code and that I'm declaring that the user is subscribed? What if that's in conflict with the payload that I send in, or if I haven't specified anything like that in the payload? I think it's fraught with problems, and I think what this is trying to tell you is use the query string not to actually define resources, but only for refining GET requests on resources. I think that's a best practice. How about /users/me? What does this thing mean? As opposed to /users/5638. So the first one obviously refers to the currently logged in user, or the user whose authorization credentials have been submitted with this API request, as opposed to a specifically identified user. There's an advantage to using /me, which is I don't have to go and figure out what my user ID is. There's a disadvantage that, well, it's obviously the meaning of me changes with different users. So there'll be cases in which you want to use one or the other. Your mileage may vary. Here's another example. Here's the way to specify all the books owned by this particular user. Now, what does it actually mean, owned by this particular user? That will be up to your domain model. There may or may not be sort of a special relationship that you want to associate this kind of path with. Is it the books that I have an access rights to? Is it the books that I've literally bought? That'll be up to you in structuring that API. How about a specific book that I own? You could construct a URL like this, right? It tells you for this user and for this user's books, here's a particular book. But how about just referring to the book like this? You can get all of the books by /books, but that particular one you can get at directly through the overall books collection. And I think what this is illustrating is that if your hierarchy is too deep, you might want to find just ways to go and simplify it. In this case, there's no reason to reference a particular book because it belongs to me. I might as well just reference that particular book globally. The next thing with REST is to look at methods. What manipulations can you do on those resources? And those are the verbs of your API. Fortunately, in REST HTTP, these verbs are completely predetermined for you, and that's a good thing. That gives you a pattern that you and everyone else can follow. A GET request is to retrieve a individual resource, a collection of resources. Very important that that GET be idempotent. And again, I'll illustrate by example. There's a relatively well-known API out there today that uses GET requests for everything, and in particular to effect changes on let me say physical objects. I won't necessarily name the company by name, but its API says you issue a GET request in a particular way, and let's say a door opens, right, or a lock unlocks. Well, you can imagine that your networking infrastructure in the middle of that API request might say, wait a minute, this is a GET. I just saw that GET a moment ago. Let me just return to you the answer from cache and not even bother hitting the end server. And guess what? Your lock doesn't unlock. Your door doesn't open. So you want to kind of go with the flow on these things. And if the spec says that GET is supposed to be idempotent and not have side effects, don't rely on its side effects in your API. A post is usually used to create a new item in a container. Not universally, it's actually much more general than that, but that's a very common use case. That's a good use case for post. If you want to update a resource, you have put and patch. The semantics is technically supposed to be that put gives you an upsert of a new resource. So you basically will replace a resource, or you can use it to create a well-defined resource. But if you have just partial resource updates, let's say you want to update a couple of fields in your resource, you should probably be using patch. Delete, pretty straightforward to remove a user, to remove a resource. There's a couple of other methods here that are perhaps less known. One is a very useful one called head, which is basically defined to be the same as a GET but without a body. So you get the headers, you get the metadata about the resource without necessarily the expense of fetching the actual resource. And that's very useful in many cases, so definitely pay attention to that one. Options is a different kind of beast. It's supposed to get you metadata about the service itself. For example, which methods are available, or even, is this service around? And the problem with options is that it's not cacheable. As a result, you need to at least if you're following the spec, issue options requests all the time. And I think as a result of that, people have kind of not been using options very often. How about status codes? So you issue an HTTP request, you get a status code back, 200 or 404 or any of those. They are very well standardized. They are very well thought through. My number one caution to you is use them as they're supposed to be. There's sort of this notion of passive-aggressive APIs that always return a 200 and then tell you if there's an error inside of the body. That is a bad practice. No matter what, that's a bad practice. If you return a 200 or a 202 and you say it's okay, I'm assuming things are okay under the covers. So stick with that. This is not a place where you want to pull any surprises. If your client developers are smart, they will rely on these HTTP status codes, and you want to go along with that reliance. If you don't, your clients will break. How about headers? There's also a very rich list of standard headers that people use. Of course, you can create your own headers, and sometimes there's good reasons to do that. But before you create your own headers, look at the list of headers that are already there. People have put a lot of thought into caching headers and authorization headers and forwarding headers and so on, and use them whenever possible, and use them according to the semantics that they're already there in the standards, in the RFCs. Because again, a lot of people put a lot of thought into that, and by piggybacking on that, you will also contribute to a much more uniform and much smoother on-ramp for your developers. Okay, how about your specific API, right? So you're building an API for some very specific purpose. How do you go about doing that? Well, there are lots of ways of specifying your API, and we like the RESTful API modeling language, at least for RESTful APIs. We participate in the raml.org workgroup. We're leading that workgroup, and we think that RAML offers a ton of advantages to providers of APIs as well as consumers of APIs in the following ways. first, let me take you through a very quick example of RAML. Somebody was asking me a while back, I guess it was last summer, to describe what an API actually looks like. It kind of took me back for a moment. How do you describe what an API looks like? It's just an interface. What do interfaces look like? And for REST, at least, I think RAML pretty much shows you what an interface looks like, what an API looks like. If I just look at this thing, it looks to me like I've got /products that has a get and a post, and inside of that it has /product ID and so on. It actually looks like what I would picture in my mind an API to be. RAML has some very specific advantages in this way. First, it's very clean. It's got a minimum of cruft. It clearly lays out the structure of your API, and yet it's got the power to describe pretty much any reasonable HTTP API out there. So it combines power with a certain sense of cleanliness, which I think time and time again we've seen out there that if you've got that combination, that form of describing things tends to last a long time, tends to be attractive to consumers, specifically to developers, so it gets adoption, and it tends to live for a long time. It is, we like to say, 100% natural and organic, right? It doesn't have a bunch of constructs that are outside of the world of HTTP. So we think that it kind of flows with REST, flows with HTTP, flows with the way that people think about APIs. It is an open spec. It is vendor neutral. It is not specific to anything that MuleSoft is doing or other vendors are doing. It really tries to just focus on construction of RESTful APIs in a very natural way. It's practical. So rather than being dogmatic about you should create your APIs in this way or else we don't support them, it tries to actually be very practical towards the way that people are building APIs today, and it's likely that whatever API you have in mind, if it's moderately RESTful, can be modeled within RAML. Pattern-based design is built in. This is actually really important. We want to make sure that RAML makes it easy for you to design APIs cleanly, right? We want to allow you to design APIs as you wish, or to express APIs as you wish. But to the extent that your API is consistent, is pattern-based, is clean, to that extent, RAML actually makes your API shine even more. It becomes quite short and quite expressive if you can make your API very pattern-based. And if you do make your API very pattern-based, then extending your API, building out more pieces of your API becomes trivial with RAML because you can rely on those patterns, incorporate them into RAML. We'll see a little bit more on how that's done. If you want to read more about this, go ahead and go to the raml.org site and you'll see a lot of examples of this. Okay, so now let's look at some considerations in designing your API. So one important thing we talked about it briefly at the beginning is aligning to a logical model. Let's look, for example, at an API that's around user authentication or user permissions and groups and things like that. So a very simple API would say, here is a collection of all users. Under that, you can refer to a specific user, and then you can have a collection of the groups or roles that that user belongs to. You can also allow direct access to all of the groups or by group ID, and for a given group, /users and /roles are this group's users and this group's roles, and finally on roles themselves you can refer to the collection or get an individual one. It's a very simple, very intuitive layout for everything having to do with managing users and groups. Very simple API, good clean design. Here's another API that's more in the e-commerce space, or that rather it's a bunch of patterns in an e-commerce API that have some interesting thinking behind them. One is, what's the notion of logging into an API? And there's lots of opinions about what that would mean, whether that even means anything in a RESTful API. But one of the interesting things you can do is you can actually just post to a /sessions collection of sessions. If what you're trying to do is to establish a new session, go ahead and use HTTP semantics to create a new session. You'll get back something with a session ID, and you can use that in order, for example, to authenticate into the further API calls or just to reestablish that session context. If you'd like to log out, that's effectively deleting that in particular session ID, and you can verify your authentication by trying to fetch that session and seeing whether the thing that comes back does so successfully. Another question that often comes up is in the context of products. So let's say I have a collection of products under /products, and I can refer to an individual one by its product ID. Now, what if I have a shopping cart model in this eCommerce API that says that you can have things in your cart? Are the things that are actually in the cart items collection specifically products? Are they exactly the same as products? Well, one consideration is the price of an item that's inside of the cart identical to the price if you were to fetch the product directly? The answer may well be no. You may have actually put in there the price that they got at the time that they picked out that item, which may be different than the current price. So these are the kinds of things that you have to think about when modeling your domain. How about looking at orders, right? And this gets back, or this will go to the question about transactions that we'll get to at the end. What happens if I actually want to submit an order? I can go ahead and post to the /orders container a specific order ID and have that be the semantics for the transaction around actually making an order happen. I'll let the systems behind the API take care of all of the transactional elements of this, to either charge my credit card if the order succeeds or not charge my credit card if it doesn't. But if I get back a successful creation of an order, then I expect that everything behind the scenes will have happened behind it. And that's a way to realize transactions in what is effectively a transaction-less model, which is REST. Here's an example of a pattern that you see often in RESTful APIs that RAML actually allows you to capture and name. Let's look at some API patterns and start with patterns that you'll see in resources inside a RESTful API. RAML actually allows you to capture those patterns and call them resource types and reuse them over and over again throughout your API. One common pattern for a resource is a collection of items. Another one is a member of that collection. And whereas for a collection, you would typically implement the get and the post, for a member, you would have get, put, patch, and delete. There's no notion of posting to a member because you're not adding anything to that member. And there's no notion usually of deleting a collection because you don't take away the entire collection, you just at most empty it out. So collections and members are very common types of resources, and RAML allows you to declare them as specific resource types so you can reuse that same pattern over and over again throughout your API. Another common type of resource is a read-only resource. One way you might declare that in RAML is as a read-only collection or a read-only member that only have get methods associated with them. Yet another kind of common pattern we saw before is, say, /users/me, where the user ID itself need not actually be a globally unique identifier. It could be actually contextually meaningful identifier like /me. And another pattern is a one-off resource. So usually when you see that a collection has members inside of it, that's a very common kind of pattern. But could a member ever have another member inside of it? In other words, can something that is a single thing have something else inside of it that's a single thing? It doesn't feel right, and yet there are actually many cases where one-off resources do make sense. Here, for example, we have an API for an ordering system that has to do with physical goods. And in physical goods, you often have a bill of materials, a BOM. So you would say, okay, I'm going to submit a proposal to fulfill this order. That proposal has a certain ID. And one of the things about that proposal is a bill of materials. Why don't you put the BOM items directly under proposal ID? Well, there might be information associated with a BOM here that's not specific to any individual item, but that's correct for the collection of items. And that might be, for example, the total of the items or the dependencies between these items. Those might be fields that make sense on a BOM. And since you'll never have more than one BOM in a proposal, you have a singleton item there called the BOM that has to do with a set of resources called BOM items. If you're looking for patterns on methods, here's some patterns on methods that RAML calls traits. One particular pattern of methods is paged. So when a method is paged, it will refer in this case, it will require in this case query parameters. What's the start page and what are the number of pages that you want? And usually you would say that a get method is paged. It isn't something that you would usually associate with other kinds of HTTP methods. In other words, another one is searchable, where it requires a query parameter of Q. And this is completely up to you to define, right? The point here is that once you define it, use it consistently throughout your API, and you can encourage that by giving it a name, assigning it to a trait, and using that trait over and over again throughout your API. Here's an example of that. Let's say /books is of type collection. We saw resource types in the previous slide. And its get method is both paged and searchable. And that's a good declarative way to say, hey, when you invoke this method, you can give it start and number of pages as query parameters, as well as queue if you want to get a specific book with a certain query string. Body schemas, and I'll go quickly through this because we're kind of running short on time. The idea is that RAML supports out-of-the-box XML schemas and JSON schemas, and it's good to put a lot of thought into schemas. A lot of people don't actually do that, but at the very least, put some thought into the examples that you put inside of your RAML spec or inside of your documentation to guide users as to how they're supposed to actually use this API. So here we see for a particular media type, application/JSON, that here's an example of a request that you would post to it. Another way, instead of JSON or XML schema, is just to use effectively good old form data, right? Name value pairs. RAML provides you a very simple way to specify what are the inputs. Here you see that a name and an email are both required. Security schemes. Again, something that RAML has paid some specific attention to because they are so common across APIs and because we want to minimize the number of people who end up reinventing this pattern. Right? The simplest way that you would give access to an API is you say there's some mechanism to acquire a token and then use that token to actually make API calls. Another area that you should pay particular attention to is security, and RAML provides something called security schemes to try to capture the common security paradigms in a reusable way, as well as to allow you to extend them into whatever way makes sense for you. And whether this is something as simple as basic auth, or even simpler, where you don't even need a security scheme, where you just say, here's a required token, please submit it on every API request, all the way through OAuth 2, the latest version of the OAuth protocol, where RAML allows you to even have multiple OAuth providers. This is not as uncommon as it seems when you want to say you can use multiple OAuth providers in order to authenticate into my API. So there's a type field. The common part of OAuth, the part that actually describes the behavior, is identified or described by the described by property in RAML, and that tells you how does this security scheme behave, what headers does it require, what responses does it come back with, and then the provider specific part is specified in the settings. What's the access token URL, the authorization URL, the types of grants that this API provides, and so on. And a particular example here of an API for files access is secured by two types of security schemes, which means you can use either of them in order to gain access to this API. Okay, here's a few more words on elements of API security. And I'll rush through this because really talking about API security can take an hour on its own. Just some things to think about. If you are going to use usernames and passwords, be very aware of whether this is an end user that's going to access your API or it's server-to-server communications. And ideally get out of the business of storing usernames and passwords. So worry about who stores it. Ideally, the answer isn't you, but someone who is concentrating on, say, tokenizing usernames and passwords and taking care of all the stringent security around that. If you do end up actually storing the usernames and passwords, make sure that you use a one-way hash with a salt and take all of the by now standard precautions around that security, because realize that if your username password store is compromised, those same usernames and passwords are, for better or worse, likely to be reused by users in other places, so you end up causing a much bigger breach than you even realized. And finally, of course, minimize the places in which these credentials are exposed, both in transit and on the client. There's lots of good guidelines that we could talk through it at a future webinar. Tokenization is incredibly important. As quickly as possible, exchange the sensitive credentials for shorter-lived credentials, namely tokens. And beware of whether you're issuing tokens for an application or whether these are tokens really meant to reflect the end user. If you do need three-way authentication, OAuth 2 is the way to go. There is some complexity, so allocate yourself enough time to go and study this standard. It is non-trivial to study this. And don't try to reinvent it. Don't try to be different about it. Implement the spec per the spec. It's hard enough to go as it is. And of course, the standard HTTP security principles that you learned in creating web applications definitely still apply. Don't have very chatty errors. If your application does have an error, the default should not be to throw all of the details of your internal implementation to the client and let them not only figure out what's going on behind the scenes, but maybe compromise what's going on behind the scenes. So beware of chatty errors. Use good URL hygiene. Try not to put sensitive information in the URL if you can at all avoid it. Some very basic things that definitely apply to the REST and HTTP API space. Think a little bit more about the nature of the API. This is a little bit of a grab bag of things, but really important considerations. Is your API coarse-grained or is it fine-grained, right? Do you need to make lots of API calls to get through a business flow? That might actually be a good thing. You often need to make that in order to allow your API to be used in multiple ways. On the other hand, there will be clients for whom making lots of requests is really unacceptable, so provide them with coarse-grained requests that they can get what they need done in 1 or 2 calls. People often talk about bandwidth, but latency is at least as important, right? Latency is caused effectively by the speed of processing and even more commonly by the speed of light. It takes a certain amount of time for a signal to get from place to place. So if you need to make 4 API calls and they have to be sequential because the second one depends on the first and so on, the latency is going to be the sum of all those latencies. And that's not something that you can reduce by throwing more horsepower in. You actually need to redesign things in order to improve that. So think a lot about latency and how many calls it takes to actually get something done. How about bandwidth? Well, bandwidth is the kind of thing that you can solve more easily than latency in many cases. You can compress the actual bandwidth. You can tokenize. Instead of going back and forth with a lot of information, take that information and give it a token and just pass the tokens back and forth. Partial requests, where you are only submitting part of the information. Partial responses, where you're only asking for some of the information to come back, are really, really useful. And in some cases, you'll actually abandon REST and go for a protocol that itself is more conscious of bandwidth. We talked a little bit about those at the beginning. And how about implementability? You can give a great API, but eventually you'll have to actually implement that. Make sure that you've thought through at some point how you're actually going to implement it. This is where you want to make sure that you have an integration or orchestration layer that are very scalable and maintainable, because if your API strategy is very successful, you will end up growing that API layer and you'll want to evolve it over time, and you don't want to get into a complete hairball of custom code that every time you touch it, it breaks your API. APIs are long-lived contracts and you want the work behind them to also be very solid. Think layers, as we talked at the very beginning, and think caching. Those API calls that are just fetching over and over again the same information could benefit from a very robust caching strategy to take the load off of the back-end servers where it's not needed. And last word I want to leave you with is that good APIs are not trivial. It takes a lot of thought and it takes a lot of work to actually create long-lasting APIs, just like it does for any good product. But with the proper approach, we're firm believers here at MuleSoft that strong APIs can be your home court advantage. And with that, I'll pass it back to you, Dan.